Okay, so today on the bench we have, as you can probably see upside down here, a Cobra 2000. Customer sent this one in for restoration. It is also getting a Channel King board. Now, when I do the Channel King boards, basically the radio needs to be, as far as the PLL and the synthesizer circuit, needs to be factory, because it's just meant to pull the PLL chip, just stick the adapter in. It's a little bit more complicated than that, but it's meant to be used in a radio that's basically unmodified. So you have to put the radio more or less back to an unmodified state. Now, there's nothing wrong with doing, switch mods. Granted, it was done rather hacked, in a hacking way. I guess you could say they drilled 3 holes in the front of the radio. And this, you'll see it later on in the video once it's turned over and whatnot, but this radio is in really nice condition, with the exception of it's got 3 holes drilled in the front. And they're not even, honestly, in a perfectly straight line. But, yeah, so cutting traces, adding toggle switches, not uncommon. Don't suggest drilling holes in the front of the radio. I don't even, honestly, suggest drilling holes in the back of a radio. I always suggest just run your ribbon cable outside of the radio. No holes. You can just snake a thin piece of wire like this, your ribbon cable, underneath the flange, out the back side, between the bottom cover and the flange of the radio, and then just get a little plastic project box, and you can put your toggle switches in it, and then, just set it beside the radio. And that way, if in the future you want to sell the radio, someone wants the radio unmodified, you just unsolder your wires, pull it out, it's back to factory. No holes drilled, there's no switches, thank God they didn't undo any of these. A lot of times you'll see the switch panel here with butchered traces on it because they repurposed these for the channel mods. But, like I say, it makes it very simple to undo. But you can probably see there's another switch, and that would be this one. Well, this is the one that's absolutely not the way to do a channel mod. Like I say, this is common toggle switches. Now, depending what crystal your radio has in it dictates what your frequency range is, where it's going to begin and stop at. And that's a limitation. So another common modification would be to just change out the oscillator crystal. No, they didn't just do that in this. They just completely removed it off of the board, stuck it on the bottom of the board with some hot glue. No problem with hot glue, I just have a problem with how this modification's done. Tacked a trimmer capacitor onto there, added an additional crystal to get some extra frequency range coverage, because they needed a crystal so they'd have range in the other direction. Again, added a variable capacitor. That in itself, bad enough, it's right here. What makes it so bad is all of these wires. What are these wires attached to? These wires are attached directly to the crystal, okay? It's right there, to the crystal. What do you think that's doing? And I've shown this in other radios that I had them turned on, and you just bump the radio like that. Just the slightest tap on the radio, and when the radio's in sideband, you'll hear it. The frequency changes. Temperature change. This thing has got to be one of the, it's going to be one of those worst radios there is for stability because of this. As temperature changes, the copper wire is going to expand. The copper inside of the insulation here. Copper, things like copper and aluminum, non-ferrous metals, expand and contract a lot. And the wires are going to move a little bit. Well, these wires, since they're actually in the oscillator circuit, they run from the crystal up to the toggle switch, and then back from the toggle switch, from the center contact, back down to the circuit board. Well, that means all of these are acting just like inductors and capacitors. So the slightest bit of movement, tiniest amount, something you couldn't even see with the naked eye, just the tiniest amount of movement of these wires is going to change that capacitance and inductance, and it's going to do the same thing as an adjustable trimmer capacitor is. It's going to change the frequency. So your frequency, it's just took a good stable radio platform and just turned it into a drift monster. That's basically what you do when you do stuff like this. This is not the way you should do channel modifications. This, like I say, the only problem I had with this modification is that they drilled holes in the radio. Doing it at the PLL, that's common, not a problem. Just try to be a little bit more neat about it without destroying faceplates on radios. This, on the other hand, Yeah, that's a big no-no. Don't do stuff like this if you play. Now, if you're talking on AM, yeah, honestly, who's going to know? You could have a couple hundred hertz, good Lord, close to 1,000 hertz of frequency drift on AM, and yeah, your signal will just start to get weak to the receiving station. You'll slowly fade out, but you're not going to notice, a warble or frequency drift where you're continuously turning your clarifier. On sideband, yeah, this here destroys frequency stability on sideband, where a small change in frequency is audibly noticeable. And like I say, you'll just be chasing people with the clarifier just continuously as the radio changes temperature. If there's a vibration, you bump the radio. Yeah, you're always going to be chasing people with the clarifier. So, big no-no. So, let me get to it. Like I say, actually, let me just flip it up so you can see the top of it. Shove these up in here for a minute. Like I say, this is actually a very nice, clean radio. The top cover's in really nice condition. The faceplate is pretty nice shape. It's got a little ding there, which is the one thing I don't like about these radios, because they have this panel it's not straight up and down. Anytime you drop anything, yeah, it's easily damaged. So yeah, there's a little ding there and a little ding there. Other than that, it looks good. It's not worn out. It's just, it's got those blasted 3 holes. So, yeah. So the customer, he wants variable power in this. I don't know if I'm going to do it with that. I might just put a double control in somewhere on here. Because he's talking about getting himself, just doing it himself, getting a sticker kit to try and cover this up. And if you're, the owner watching this radio, what I would suggest, don't just apply your sticker over top of this as it is right now with the holes. Because that sticker, it's just that. It's just a piece of vinyl decal material. You're very easily going to see those three. You just touch it, it's going to deform because it's really thin sheet of plastic. What you're going to want to do is fill in those holes. Before you put your new sticker on here to cover that up, actually fill those holes in with something. I just use Bondo, automotive Bondo, something like that. Something where you could use JB Weld, but something solid. You want to make this solid. Then you could sand it down. Then when you put your new sticker over top of it, it'll be a perfectly smooth surface, and you won't have those holes basically showing through the sticker. Internally, really nice, clean condition. Got a few little dust bunnies in there, but because these have the double cover, it has the metal shield, and then it has the wooden cover over top of it. These radios are usually fairly clean on the inside because it's actually kind of hard for dirt to get into them. But yeah, it looks pretty good. Not that it matters because the PLL is coming out because it's getting a Channel King board. But yeah, the glue in this one, they weren't being generous with it the day this radio was put together. So yeah, there's actually no glue even. There's a little bit here on this side of the cap, but nothing had leached over here. A lot of times you'll see it surrounding this crystal all over the back couple pins of the PLL. Looks like there's a little bit might have gotten down on the VCO block, so I will pull that and make sure I get all that goop off of the pins of the VCO block before they corrode off. You can tell it has been screwdriver tuned. You can see the coil that's been spread to the max here. Yeah, that should be, we'll just take care of that right now. I'll have to actually tune it with a spectrum analyzer, but yeah, it's not supposed to be, it should look like that. At the most, if you see coils like this, now a lot of people I've heard and have been asked questions about, with these fixed inductors, they're non-tunable, so they don't have a ferrite core like this. They're not on a coil form with a ferrite core, so they're not adjustable. It's just a coil of wire. They'll say, I open up a radio and I see that it looks like, just do one really quick, like, well, maybe not like that. I'm trying to work around a camera, which is almost impossible. But they'll just have, like from the center, there'll be a gap. But the rest of the coil, the rest of the windings are still close together. That was probably a factory tune. Okay, so it'd be the same thing when I do the alignment on this. If I need to adjust any of these coils, what you should do is you should go in starting at the middle, just stick something down in there and spread it into basically 2 blocks. But you shouldn't have all of the windings spaced far apart. So yeah, it is common in some radios to see some spreading of the coil, but it's usually not going to be very much because the inductance of these coils was picked. They know it's fairly close. It just needed to be fine-tuned for the circuit. And since it's not tunable with a ferrite core, how you tune these is actually spreading the coils. But like I say, you need to do that kind of in a not a haphazardly fashion. You just don't start on one side, just grab both ends of the coil and go and turn it into a stretched-out slinky. So, but yeah, like I say, nice and clean. A little bit of glue around here, but it's like I say, they didn't use very much, it looks like. I'll need to get the crystals taken off of the bottom, put the crystal back up on the top of the board here, because that's where that crystal is supposed to be, on the top of the board here. I'll get that reinstalled. Yeah, otherwise, doesn't look bad. I haven't even looked to see. I'm going to assume that's spread. It's probably, and I haven't even turned this on yet. I'm going to assume probably there's something clipped, or the modulation limiter is probably missing. Just when you see stuff like that, yeah, there's usually going to be some hackery going in the AMC ALC circuit, so I'll make sure all of that, if anything's been done there, it's been re-enabled. But there you go. There's just a quick overview of it before I really get anything done. Like I say, the only thing I have actually done to it so far is I just took three switches out, and I'm getting ready to put that back to factory, take those crystals off the bottom, and put it back the way it's supposed to be. So next time you see this, it should be probably recapped, deglued, fresh heatsink compound, have the Channel King board installed, and alignment should be done. Unless I run into anything I need to do any troubleshooting, I'll show what it needs and how to go about it. But I don't foresee it. Like I say, it looks like a fairly clean radio. Had a little bit of hackery done to it, but it hasn't been butchered on for decades. Looks like basically it got into probably one time, and that was it. So I shall return. Okay, so I got her pretty much done now. I just need to put all the covers back on, do the final cleanup on it. Like I say, the customer just had the extra channels done with toggle switches, which have been removed. So now there's 3 ugly holes in the front of the radio. Probably, he said he's gonna get a sticker kit for this to fill it in, and like I'd previously said, you can just fill those holes in with something, because you want this to be perfectly smooth before you stick your decal on there, or it'll show a depression there. Probably what I'll do is just stick some screws in there, some polished stainless steel head screws, just temporarily to fill the holes in, so it's not ugly to look at until he gets that done. He had wanted variable power on this, so I did install that. You'll notice there's now a third double control. Originally, these only had the two controls here, your clarifier, and has a fine coarse clarifier and an RF gain SWR control. But it had a single control with a knob like this before, which was for the tone. This now has variable power on this bottom or back control, and then the tone is the outside control. So obviously it has the Channel King board installed because we're on channel 200, and this originally did not have a 3-digit display. Now the customer had asked if I could get a lot of channels out of this. He had seen a video I did on, I guess that was probably the 148F GTL, or the DX version, which the one that's was actually made by Ranger. So those radios do not have circuit boards made by Uniden. They were made by Ranger. And the first one of those that I stuck one of Mark's Channel King boards in, I found really quickly that those things do a lot of channels. I mean, just an insane amount of channels. And it's the same circuit board pretty much. The only difference is Ranger's using some of their parts instead of using the parts that Uniden used to use. So like all the transformers in those radios are the same as you would find in anything made by RCI Ranger. They use their own VCO blocks and a lot of other parts. There are certain subtle differences in the circuits. Customer wanted to know if I could get crazy numbers of channels in this. Now, honestly, I don't think anybody would really be using those. But I think it's more of my radio's got more than your radio complexes. But I wanted to give it a try. Yeah, I can get crazy numbers of channels on this. I was able to get this radio with a modified VCO block. Actually, it's right here. I was able to get this thing to transmit with at least 1 watt of power. So it still had 1 watt, you key it in AM, and you could still have a 1 watt carrier over 4.55 megahertz. So yes, a whole heaping helping, or 455 channels. It went from negative 99 up to whatever, just an insane amount of channels. Now, the problem you run into with stuff like that, the first thing you're going to run into is, at that 1 watt power level, there's really no modulation to speak of. You'll have let's say a 1 watt carrier, and modulated, your peak modulated power, using a peak reading watt meter, is still going to be 1 watt. It's just, once you get to a point where, the radio just wasn't designed to do that. Now, like I say, it would transmit. I quickly found, though, the instant I changed modes. So if I'd switch back to lower sideband, so, if I was on channel, I didn't even have to be up that high in channel, only at like 120 or 150 or something like that. When I'd switch into sideband and switch, you could see the frequency counter would go all wonky. It would show 32 or 33 megahertz. The last couple digits would be bouncing around, and you couldn't transmit and you couldn't receive because the VCO had unlocked. You check the VCO voltage. Yeah, it was stuck at 8 point something volts. But it would then occasionally, and the lower you were in channels, it would lock up. But there was a delay, and ever increasing the delay, the higher you got in channels. So you're starting to run into that roadblock of the charge pump and the phase detector with the PLL circuit, because you have to remember the PLL and the VCO block, one of these VCO blocks complement each other. But yeah, you're starting to run into a problem there. And like I said, there's other components in those radios. I just really need to do a lot more research on that, trying to see what I can do to get a fairly flat power across a really large frequency range and still have modulation. That's the whole key. I don't care if this radio would do 5 watts over the entire frequency range. It doesn't do you any good if there's really no modulation to speak of. So like I said, I need to tinker with that some more. So I put the original VCO block back into this radio, and it will get, as you can see, we're on 29005 to 26465. So channel minus 50 to channel 200. So it gets 250 channels, which is impressive in itself. That's 2.5 megahertz worth of frequency coverage. Now, like I say, I could get 4.55 megahertz worth of frequency coverage, but the transmit power had dropped. And even in this, with the original VCO block, and that's another thing to understand, with the factory VCO block in here, even with some circuit modifications to try and even out or broadband the transmit power, you're still, when you get to channel 200 or channel minus 50, you're still down at about 1 watt of carrier. It quickly comes up, though. So, it'll receive and it will transmit, but your power is dropped off. The problem I was having with using a modified VCO block was that the VCO would unlock. And it was, like I say, you'd have to wait, or you'd have to come back to your, like in this case, I have channel 19 set as the home channel. When you press the encoder, it jumps it back to channel 19. It was just that instability, and it just had that ever-increasing lock time. So yeah, I'm not going to let something go like that, where it's the PLL will not reliably lock. This one, as it is now, reliably locks with the factory VCO block. I'll have to do some, it'd probably be a year I can get around to doing some major tinkering with one of these chassis till I get the electronics course going, which hopefully will be next week. Actually, by the time this video comes out, the course might be up, I don't know. But like I say, once that gets going, I'll have more time to tinker with stuff like this, trying to basically duplicate that extremely broad channel coverage. So, like I say, otherwise, really all I need to do is I think the other thing was, a lot of the lights were out in this thing. Originally, I think both the meter lights were out. The AM light was out, and the receive light. Yeah, both meter lights, AM and the receive light, were out. It did have lower upper sideband, and the on-air light were on, but that was it. So all of the light bulbs were removed, and they've been replaced with LEDs. So that took care of that. Should never have to worry about bulbs burning out again also. And you'll notice that when I turn the radio off, there is no afterglow. That's a big problem with these radios. if you just pull all of the light bulbs out. Actually, if you change all of the light bulbs except for one light bulb, you won't have that afterglow. And what I mean by afterglow is you'll see, like if you're in AM position, you'll see the AM light just barely glowing. Or if, especially in a dark room, and you'll see the receive light, it'll be just slightly illuminated. If it's not modified with a Channel King board like this, if it still has the factory channel selector and display, you'll also be able to see your channel numbers. And with the radio turned off, you can turn your knob and you'll see the channels changing on the display, even with the power turned off. What causes that is these radios do not switch with the power switch right here, your on-off button. This button does not control the 13.8 volt rail to the radio. The chassis right now, if you go and take a voltmeter and measure from your power supply DC ground, and you measure to any point in this radio, there's on 13.8 rail in there, you're going to find there's 13.8 volts to that board right now. The on-off switch in these radios switches the ground. The reason they did that is because this has a clock, and more importantly, it has a clock with an alarm, so it can turn the radio on and off. And the way they did that was with ground switching. So what this power switch actually does is, when you turn the radio on, you're actually connecting the ground, the DC ground, to the circuit board, which turns it on. When you take all the light bulbs out, what happens is, if you leave one light bulb in and change all of your other lights to LEDs, you're golden. The instant you take out that last light bulb, you'll get that faint afterglow effect. The reason is, there is a small floating voltage there because of this kind of oddball power supply circuitry they have set up with this clock. There's a couple volts there, like around 2 volts. Well, that's just enough to turn on a diode. You got to remember, diodes, the forward voltage is less than a volt. Now, granted, between a volt to 2 volts isn't enough to bring on an LED light to full brightness, but it is enough for it to illuminate slightly and you can see it. So and that's what that one light bulb, if you leave one light bulb in it, that has enough to draw down that voltage to the point that none of the LEDs will turn on. The instant you take that light bulb out of circuit, there's that voltage present now, because it's not being dropped, and you'll get that afterglow. So yeah, like I say, that's, as you can see, no glowy lights when the radio's turned off, so we don't have that problem. Like I say, it wasn't a lot to do on the inside. It was a really clean, it was, fairly clean radio to start with. I'll finish this video up with, I'll have all the cover and everything installed so you can see it all together. But, so replaced all the electrolytic capacitors, installed the Channel King board, removed all the heat sinks and applied new heat sink compound, cleaned everything up. Well, I had the heat sink out and had the can cover off. Well, actually, I had the entire clock frequency counter module out because I had to recap it as well. I went ahead and polished those up a little bit. Not like anybody but me is ever going to see it again. I mean, the only people that ever see this stuff, I mean, granted in this video, but yeah, are going to be techs when they're working on a radio. But yeah, well, you got it out easy just to clean them off really good. Removed the corrosive glue. Luckily, that wasn't too bad in this radio. There were only a few little spots where it had done a little tiny bit of corrosion. Stuff was changed. The AMC limiter had been removed out of this radio. That's been reinstalled, so the AMC circuit works. There were a few other modifications someone had done. They modified the ALC circuit slightly. That's been removed. All they did was changed a few resistor values. That was replaced. There were a few parts in here resistors that were changed. I don't know if there was a problem, possibly at some point in time. This resistor back here, I don't know if you can see it in the camera, but it's blue. Well, the resistors of this vintage in this radio should have the tan body color. They shouldn't be blue. That's obviously a more modern replacement. The thing is, it's the correct value. So it's not like somebody changed anything here. So yeah, I don't know if maybe the resistor had burned up. So there might have been some minor repairs to this. But yeah, overall, it's, like I said, there wasn't a lot done to it. AMC, which is honestly most radios, probably 80% of the ones that I see, the AMC ALC circuits are modified or just completely disabled. So yeah, like I say, those have been put back. The other things I saw, it looked like somebody just took out or had replaced a part with the correct part. So there's no need to change those. I had taken out this, they're actually laying over here. I had taken out this crappy channel mod with the long wires. Like I say, they're just horrible when it comes to frequency stability. There is none. When you do mods like this with the long wires, because you can see there's a green wire there. It was soldered directly to the crystal. Now, the one crystal I had to reinstall on the radio, the 11.1125 megahertz crystal, which is right there, is the correct one that should be in the radio. So I just took the hot glue off of that, took the wire and the trimmer capacitor off of it, and stuck it back in the board as it's supposed to be. And I think other than that, it was pretty much a stock radio. The clarifier was already unlocked on this, so I didn't have to do anything there. And other than that, like I said, stock radio. All original semiconductors from the look of it. So driver, final, all the voltage regulators, everything's basically as it left the factory, and absolutely no need to change any of them. I know a lot of people say, yeah, well, shouldn't I change the voltage regulators or the driver and the final? Why? Does the radio work? Is it working fine? Yeah? Well, why would you change it then? There's nothing wrong with it. It's working fine. It may work for another 100, 150 years just fine. Semiconductors just, it's not like an electrolytic capacitor. Electrolytic capacitors go bad with time. You just set this radio on a shelf, come back 30 years from now, that cap may be bad. It's just a time thing. That's why we replace electrolytic capacitors. They age. But most of the other components in this radio, transformers, now crystals age. Crystals, that's actually another thing that does change, is crystals. They do drift in frequency. But yeah, when it comes to semiconductors, polydip capacitors, ceramic capacitors, like I say, all these transformers, potentiometers, wire, this stuff, semiconductors, transistors, diodes, Zener diodes, none of this stuff is going to change. It's going to be, if it's fine today, it'll be fine 50 years, probably 100 years from now, and even farther. As long as the radio's still around, those parts will probably still be fine. So yeah, it's just no need to do that. Don't need to go modifying a bunch of stuff. Like I say, the only thing I really got left to do on the inside here is finish tying up the wiring here at the front. I had rebundled all of the wiring back here. I just have to finish tying up all the wiring here from where I installed all the LEDs, and the last little bit of wiring here for the Channel King board. But let me just turn it off and actually just get her flipped over here. Here's the underside. So there's not too much glare. So, like I say, of course we had the Channel King board in here, so this has wiring that runs to the microphone jack for the push-to-talk button, the Roger Beep, noise toys that are built into that channel board, so you need to tap into the audio circuit. So, lots of wires were run down here. One thing I don't know if I mentioned before, the clarifier was unlocked, but they did it in a not-so-great way. They had this black wire right here attached right there. That's the voltage supply for the PLL chip. That's not really a good place to be tapping in for voltage. Even if something like that is running off of the same voltage regulator circuit. So, let's say this voltage regulator over here is supplying that voltage right there. The problem is, there are capacitors here to store charge, okay? They're meant to stabilize that voltage because there's lots of circuit traces. You'll have drops, you can have dips. That's why you see electrolytic capacitors all over a circuit board. And on a power supply rail in a radio, you'll see a cap probably right by the voltage regulator. You may find one here. You may find another electrolytic cap here, one here, one here, and one here. They place them all throughout that power rail because there can be a dip in voltage back here, and there won't be any here because the load, may have a higher load back here. Well, if you go attaching stuff, especially to something, the PLL, you couldn't pick a worse thing to tap into. The PLL is something, just stay. The PLL, just like your VCO voltage, everything in here is very voltage sensitive. You really shouldn't be tinkering, tapping in, using that as a voltage source. So yeah, I put that where that should be when you do a clarifier modification on this. run it directly off of the voltage regulator. So yeah, I didn't actually have to do the clarifier modification. Like I say, that was done. I just needed to change where the voltage was being picked up. Other than that, again, just some wire ties. Also, now I didn't actually put heatsink compound on this, like actually some of the transistors on the top. I use modern sill pads on these, so, you know, just take the screw out of the transistor, the voltage regulator transistor, lift it up, clean off all the old heatsink compound, and then just put in a modern sill pad. It'll never have to be done again. 50 years from now, you come back, that sill pad will be there, because these are good, high-quality sill pads. These aren't the cheap Chinese ones. You come back 50 years from now, that thing's going to be just as flexible and good as it is today. So, like I said, that's just, if nothing else, just prevents maintenance in the future. Won't ever have to do anything with that. So, there you go. Let me get the covers back on it, come back on, see if there's anything on air. I haven't had a radio hooked up to an antenna today, so I'm not even sure if there's anything coming in. It's, what is it, 4:30 about. So, there may be, see if there's a little bit of afternoon skip rolling in. But, so, shall return. So here she is all back together. Oh, actually somebody starting to break squelch. A local passing trucker. Anyhow, got her all back together, got the cover polished up. Like I say, the only thing was having the 3 holes in the front here. I didn't want to do anything permanent because, like I say, the customer wants to cover that up. And I figured, well, if I can make it so he doesn't even have to take the cover off, because if I stick screws in there, I got to put nuts on the inside. And it'd be tricky getting up in there. So I figured, what can I do to try and fill the holes in that he can just remove from the outside? Push pins. So in the automotive, trucking industry, actually even in upholstery industry, something that's fairly common and something you can pick up on, from like auto parts stores, especially shop or auto parts stores, not so much some of the big chain stores, but like Napa or some of the ones that have a really good inventory of body hardware, because they actually do deal with a lot of body shops and dealerships. They supply parts for them, so you can ask them. Pull out a catalog, and I have cabinets full of stuff like this, and they're just little plastic, handy thing with fingernails. I can just get in behind one of these, and that's all it is. It's just a little plastic cap. Expanded. Now, these were a little bit too small for those holes. They were very loose. So all I did was, let me just reach over here and grab it. I needed to expand this ever so slightly to get it to flare out a little bit more so it was a tight fit in the hole. Just took a file. I needed something to stick in there and use, but I needed basically a wedge. So I just put it on there. It was like way up here originally. Just took a little torch, holding it way back, just gently heated the plastic. Could have used a hot air gun, could have used my reflow gun, just happened to be what I had handy, right sitting beside me at the time. But anyhow, just warmed the plastic up so it's a little bit more pliable. And then I pushed it down onto this and let it cool down. And, once the plastic cools, then it'll retain that shape. So, like I say, that flared it out a little bit more. And then that way, the customer can now, when he does get his decal kit, he can just come in here and boink, he can pop those out, from the outside of the radio. Doesn't even have to take the cover off to do it. One thing I did forget to mention was he had asked to do the seconds modification on the clock. So as you can see, it's counting. So I have enabled the seconds on this. Now some people seem to be under the false impression that people had to discover how to do this, or there's some secret to doing the seconds modification. I'd have to check, but I'm pretty sure, for starters, I actually did a separate video on that, or at least maybe I showed how to do it in a frequency counter repair module that I might have done one time. I know I've shown that, but there's no secret to it. Didn't have to figure anything out. It's on the schematic. If you look at the factory, this is actually a factory, from Cobra. There's the radio, the main chassis schematic, and there's the frequency counter clock module. And if you look at this, right, I got a pointer here, bring it up and wait for it to come into focus. Hocus pocus focus. doesn't like this glossy. There we go. You can see it says, it decides to focus again. But anyhow, that diode, you can see the dashed lines. Okay, that means it's optional. If it's a solid line, that's something that's in radio. If you ever see components that have dashed lines like that, it means it's optional, or maybe not just that it's optional, but it may not be present in a radio because it's a component that's maybe being used to tune a circuit. So it could be like a ceramic capacitor. If they didn't need it, well, they won't install it in the radio, but they'll show it on the schematic. Yeah, you can see right there, it says seconds, SEC. That's all it is. It's that diode right there. If you install that diode at that point, that enables the seconds on the frequency on the clock display. So yeah, there's no secret to that. Nobody ever had to invent that and reverse engineer the counter clock modules to figure that out. It's on the factory schematic, people. So people that are telling you that they, especially if someone tells you, oh yeah, I had to come up with a modification how to do that. No, they didn't. All they had to do was look at the blasted schematic and go, aha, diode, seconds. Put a diode in it, seconds work. Yeah, But in any case, so there you go. Like I say, it's a shame it has holes. Otherwise, it's in really nice shape. The top cover, like I said, I did polish that, so it's shinier than it was. But the bezel's in really good condition, with the exception of those holes. It does have a few tiny little dings in the... If I can get the camera angle just right so you can see them or not. Yeah, you can just see. There's a little ding there. Like I say, that's the only thing I really hate about this... The Cobra line of radios from this day. They are nice. It has advantages and disadvantages. The knobs can be, if nothing else, easier to get to. When the radios stick straight out the front of a radio, especially if they sit really low on a faceplate, well, then you got your hand rubbing against the table to try and get to a knob. If they're pointing straight up and down, yeah, then you got to lean over the radio to see what the knobs are. But on an angle like this, they're nice. They're very easy to get to. The problem with that is, the instant you drop something on it, it's aluminum. It's plastic with an aluminum overlay. And if you drop anything on it, it leaves a little dent. There's one right there, a little tiny dent there. There's a couple little tiny dents here. That's the only problem with this is it's very easily damaged. And if you put a decal over this, that will transfer through. That little depression in that aluminum right there, that is going to show through a vinyl decal, because when you push that decal down, you clean this off, put your decal on, you press it on, it's going to show through. It's going to be obvious. Now, one thing you could do to fill in imperfections like that, just think like a body man. You're basically, like I said, just like with these holes, when he goes to fill in these 3 holes, if he puts the decal on here, he could use some body filler, some Bondo. You're never going to see this again. It's going to be covered up. That's why you're putting the stickers on it to start with. So you can put a little bit of Bondo on there. Once it sets up, you can sand it flat. Make a small sanding block that just fits inside of here, because you don't want to scratch your chrome trim. You could sand it smooth. And not only that, that'll give this aluminum a little bit of tooth also for the Bondo to bond to. But you can do the same thing up here. Clean it with some isopropyl alcohol. Take a little piece of sandpaper. Scuff the area up a little bit. And when you're mixing up your Bondo to fill in the holes here, the customer could also take a little bit of Bondo and actually fill in these little divots in this aluminum trim right here. Once that's set, again, take a small, little fabricated sanding block. Sand it so it's perfectly flat. Then when he puts the decal on here, it'll look perfectly smooth. There won't be any little dips and divots in it, and it's basically just, it's going to look just like it does now. It'll just be on a new decal instead of on the original faceplate. So yeah, anything you can do to fill those in to help keep, prevent that from transferring through and showing on your decal, hey, that's a bonus. It'll look more original. So, in any case, there you go. There's another Cobra 2000 restored, and we flip back over to the frequency counter there. Like I say, main modifications, some LED lights, Channel King board. That has the normal, your Roger beeps, your memory channels, it scans, does all of its fancy things. Like I say, channel coverage on this one, I got it set from -50 to 200, which was 29005 to 26465. And yeah, other than that, the clock, variable power here, and that was about it other than a recap and a cleanup, so hope you enjoyed.